Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 12cc, Lesson 1 on scatter plots and lines of best fit. Now, you may have made scatter plots before in science classes. You may even have drawn a line of best fit on those scatter plots. But we're going to be kind of taking it today from the perspective that you've never seen this topic before. Now, we're in our unit on functions, right? And functions really model inputs and outputs, right? So a value goes in and only one value comes out. Lines of best fit, we're going to see, are simply a particular type of linear function that we use to try to model a data set. So let's get into it right away. In science and other areas, we sometimes want to see if there's a linear relationship between two variables. We do this by collecting data and then plotting it on a scatter plot. So let's take a look at kind of an interesting example that hopefully everyone can understand in exercise number 1. Students in Mr. Rivera's math class wanted to see if there was an association between the number of siblings a student has and the number of first cousins she or he has. They asked 12 of the students in class and found the following. So in the first row, right, we've got the number of siblings that the person has, and we're just going to call that the x variable. Doesn't really matter which is x and which is y. And then the number of cousins, first cousins they have in the second row of the table, and we're calling that y. All right. Letter A just asks us to create a scatter plot of this data set on the grid. All right. And again, this is just as simple as basically saying, look, I'm going to take this 2, 5, and I'm going to plot based on this the point 2, 5, right? I'm going to plot that. I'm going to plot the point 6, 10, etc. All right. So what I'd like you to do is take a little bit of time and plot each one of these down here on that grid. Pause the video now. All right, simple enough, right? I'm going to save ourselves the time, and there is our scatter plot. All right, there's our scatter plot. Now, let's take a look at this data. All right, in letter B, let's take a look at what it asks us. Generally, does the number of cousins increase as the number of siblings increases? Well, and the answer is yes, right? I mean, generally speaking, right, looks like the more siblings that a person has, generally speaking, the more first cousins they're going to have. All right, so nothing more than just yes there, right? Now, letter C asks us a very important question. Do any of the data points in the grid appear to be outliers? They go against the trend. Explain. All right, so are any of the points that we plotted against the trend? All right, do any of them kind of break out of this mold that, you know, as the number of siblings go up, the number of first cousins goes up as well? Pause the video now and explain whether or not you believe there's an outlier in this data set. And the answer is you bet, right? The outlier is right here. It's pretty obvious, right? And generally, right, this is an outlier. I'm going to say the point 6, 2, because there are a large number of siblings but a small number of first cousins, which of course can happen, right? This certainly isn't a perfect linear relationship in any way. So, you know, you could have somebody who's got, 6 siblings, but very, very few first cousins. Now, let's talk about these lines of best fit. Now, in letter D, it says, ignoring the outlier from C, use your ruler to draw a line of best fit through the data. All right. Now, obviously, if we look at the data, right, the data does not fall in a completely straight line. If it did, then it would be very, very simple to draw a line of best fit. All right. So what do we mean by a line of best fit, right? What we mean is a line that generally slopes the same way that the data slopes, and generally has those data points as close to the line as is possible. Now, how do I do that? Well, I take my ruler, and the first thing I'm going to do with my ruler is try to make it more or less have the same slope as the overall trend of data. Now again, it's not perfect or anything like that. The other thing that you'd like with your line of best fit is you'd like about the same number of data points above the line as below the line. You'd like that. Will it always work out that way? No, but you generally want about that. So, maybe right now, let me draw a line on here, and then we'll adjust it if we need to. Maybe this would be a good line of best fit. Let me bring this out. Right, so, when I look at this line, what do I have? I've got 1, 2 points above it, a bunch of points on it, and 1, 2, 3 points below it. That's not bad. I could try to adjust the line in some way if I felt like it wasn't quite doing the job, right? By adjusting it down there, I've now got 1, 2, 3 points, maybe even 4 that are above it, and 1, 2, 3 points that are below it. It looks like I've got a couple points, maybe 3 points that are right on the line, and then I've got my outlier that I'm totally ignoring. All right. So generally speaking, with a line of best fit, you want it to slope as much as possible like the data is sloping, and you'd like about as many points above the line as below the line. So in other words, I wouldn't want this to be my line of best fit, because even though it might slope the same way that the data does, it most certainly, right, you've got all the data points above it, so that doesn't make any sense. I also wouldn't want a line of best fit. Can I rotate this? Yeah, I can. I also wouldn't want like a line of best fit that looks like this, right? Because even though I might have about as many data points above the line as I do below the line, it's not sloping the way the data is sloping, right? It's actually too shallow, given the data, right? So let me kind of go back to here and maybe bring this back up. All right, so there's my line of best fit. Okay, you may not have exactly the same line as I do. You probably don't, right? But we don't really have any way of really getting the best fit line right now. When you take Algebra 1, maybe in a few years, then you'll actually be able to find the exact line of best fit using technology. Let's keep taking a look at this question. All right, letter E. Is the slope of the line of best fit positive or negative? How does this relate to your answer in B? All right, well, first, right, tell me whether the slope of that line is positive or negative, and then try to figure out whether or not, or how that relates to our answer in B. Pause the video now. Well, now you might say to yourself, well, how do I know whether it's positive or negative given that I haven't calculated the slope of this line? Well, keep in mind, right, any line that goes up as we go from left to right on the x-axis has a positive slope, and any line that goes down as we move from left to right along the x-axis has a negative slope. So this definitely has a positive slope. And what a positive slope always means, a positive slope tells us that as x increases, so does y. In other words, as the number of siblings increases, so does the number of first cousins. Now let's take a look at letter F. To the nearest whole number, what does the y-intercept appear to be? What does this tell you about siblings and cousins? Well, I'd like you to pause the video now and tell me, to the nearest whole number, what is the y-intercept of your best fit line? All right, well, let's take a look at that best fit line again, at least my best fit line, right? Its y-intercept is right here, and that's equal to 2, right? Now, what does that tell me? Well, what the y-intercept always tells you is how much of the output you have when the input is equal to 0, right? Specifically, when the number of siblings is equal to 0, we would expect somebody to have 2 first cousins. All right, and that's what it tells us. That's it, right? A person with no siblings still has 2 first cousins, right? The y-intercept always tells us what the y value is when the x value is 0. In this particular problem, the x value is the number of siblings the person has, the y value is the number of first cousins they have, so a person with no siblings still has 2 first cousins. All right, let's keep going. Take a look at some more lines of best fit. Now, sometimes, as in exercise number 1, there's a positive association between 2 variables, all right? As one increases, so does the other one. Sometimes, though, as one increases, the other one decreases. This is known as a negative association. And yes, a positive association will always then be a line with a positive slope, and a negative association will be a line with a negative slope. So let's take a look in exercise number 2 at some more scatter plots. For each scatter plot shown, draw a line of best fit using a ruler. Then circle whether the association appears to be positive or negative. All right, so what I'd like you to do is go ahead and pause the video and do this for each one of the cases. Again, take your ruler out, try to fit it so that it's got more or less the same slope as the line, keeping as many points above it as you do below it, etc., and then circle whether or not the association is positive or negative, hopefully by just saying to yourself, as x gets larger, what does y do? And if y gets larger when x gets larger, it's a positive association. And if y gets smaller as x gets larger, then it's a negative association. Pause the video now and go through all 3 of them. All right, let's take a look at letter A. Here we go. All right, I've got to rotate this thing down. That's going to be about the right slope. And maybe rotate it up a little bit. Again, the line of best fit is, especially right now, kind of an art. All right, let me move this thing over here for right now. That's not a terrible line of best fit. Maybe I would have shifted it down just a little bit. Actually, I can do that with mine. I like it. Right about there. About the same number of data values above it as we do below it. And notice, right, if I'm on this curve and I let x increase, y decreases. So this is a negative association. All right? As x is getting larger, y is getting smaller, a negative association. Let's take a look at letter B. Right? In this case, maybe I'll put that right around there, rotate it up. Does that look pretty good? Yeah, I think that looks pretty good. Right? And again, fairly good line of best fit, right? Goes through the data, about the same number of points below as above, etc. Notice that if x is increasing, right, y is also increasing, and so this is a positive association. All right. Now finally, number 3, let's take a look. This one's a little bit harder to fit, right? Maybe right about there. Okay, not the prettiest line of best fit, and we'll talk about that more in the next exercise. But generally speaking, still not a bad one, right? We've got about as many above as we do below. Maybe I'd have to shift a little bit more like that. And at the end of the day, again, as x is getting larger, so is y. So it's a positive association, right? Positive just basically means the 2 variables move together. As one gets larger, the other one gets larger. A negative association means that they move in opposite directions, right? The only one of those was letter A. As x gets larger, y gets smaller, right? Simple as that. Okay, let's take a look at more lines of best fit. Now, sometimes the association between 2 variables is nonlinear, right? We talked about nonlinear functions just a little bit a few lessons ago, all right? Actually, I think it was in the last lesson. All right, these can be fairly easy to spot, or they can be kind of tricky, All right, so let's take a look at some linear and nonlinear associations in exercise number 3. For each scatter plot shown below, circle if you believe it is linear or nonlinear. If you believe it to be linear, draw a line of best fit. If you think it's nonlinear, draw a curve of best fit. All right, well, I think letter A is pretty obviously nonlinear, right? And it's nonlinear because the data goes up and then it comes back down, right? Lines don't do that. Lines go forever in one direction. Now, if I was going to draw a curve of best fit here, I might draw something that looks kind of like that, right? And it's a very similar idea to a line of best fit. You want roughly the same amount of data above it as you do below it, okay? And you want the curve to go in the same general pattern as the data itself. But this is definitely nonlinear, right? Linear functions just kind of go forever in two directions, definitely nonlinear. Now, what I'd like you to do is play around with B and C to think about whether they are linear or nonlinear. Pause the video now and go ahead and do that. All right, well, letter B is most certainly linear, okay? And we can really get a nice line of best fit by kind of bringing our ruler up. And, wow, that just didn't work at all. It's been so good for me for such a long time. I'm going to try it again, although my bet is it's going to fail again. Oh no, this time it worked. Technology. So, good line of best fit. Now, by the way, notice before we move on to C, which is the trickiest one, right, that when I look at the data values being below the line of best fit and those being above the line of best fit, it's like all throughout the range of the data, there are dots that are going below the line of best fit, and there are ones that are going above the line of best fit, okay? And that is what you typically are looking for with a linear association. But let's take a look at letter C. Letter C is tricky. Letter A is obviously nonlinear because the data goes up and comes back down. Letter B is pretty obviously linear trend, right? But letter C is tough because it looks like it could be linear, but it also looks like it could have a bit of a curve to it. Now, let's say I tried to fit this one with a line of best fit. Let's say I did something like this, right? So let's say I assumed it was linear. Notice that at the beginning, the data points are above the line of best fit. Then there's this huge chunk where the data values are below the line of best fit. And then at the end, there's a chunk of values where they're above the line of best fit. That's indicating that it shouldn't be a linear association, that it's really a curved association, you see? Because if you've got a curve, right, any kind of a curve, then what happens is if you sort of draw a line through this curve, the curve ends up being above the line in certain portions and below the line in other portions, right? And that means this is definitely nonlinear, okay? We shouldn't have these data values all below in this section and then above in this section and above in that section. This is definitely nonlinear, all right? Now, what is the curve of best fit? Well, that's a little bit more tricky, but it might look something like this. All right, and then what we're having is we're having all along the curve, sometimes there's above the curve, sometimes they're below the curve, but they aren't all above the curve or all below the curve in particular regions of the line of best fit. All right, so a nice simple introduction to scatter plots and lines of best fit. People do scatter plots and lines of best fit all the time. And they do it because data is messy. It's very rare in the real world that you can go out and you can find an association between two variables where the data lies along a perfectly straight line. That is very, very rare. And yet you can still have what's called a linear association or a linear trend, meaning that more or less the data does fall in a straight line pattern, but sometimes the data is above the line of best fit, sometimes it's below the line of best fit. Now, we also saw situations where the data curves more than it is straight, okay? And, we'll deal a lot more with curves of best fit in advanced courses like Algebra 1 and Algebra 2. Mostly from now on, we're going to be sticking with lines of best fit, but we did want to give you kind of a little bit of a snapshot of the fact that sometimes the association between two variables isn't linear and it curves. All right, we're going to do a lot more work with lines of best fit in the next 2 lessons. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.